In this video, we're going to explore the angles formed when chords intersect in the interior of a circle. But before we do that, let's take a moment and try to solve this challenge problem. Now what I want you to do is pause the video right here, and then I'll come back and you can watch me solve it. Okay, you should have tried this on your own, and hopefully you're back here with your own solutions and you can check them against my work. So the first thing we're going to look for is the measure of angle, PMO. That's this angle right here. And that's a central angle, and it has an intercepted arc of 68 degrees. The relationship is that those two are equal, so the central angle is 68 degrees. Next we'll look for angle PNO. Let's see, PNO. Here we go. That's this angle right here. That is the inscribed angle that intercepts that same arc of 68 degrees. And the relationship with the inscribed angle is 1/2 of the intercepted arc. So this angle is 34 degrees, 1/2 of 68. Next we'll look for angle QPN. It's another inscribed angle. It has its vertex on the circle. And the intercepted arc this time is 118 degrees. Let's see if I'm doing my arithmetic in my head correctly. That is 59 degrees, 1/2 of 118. Next we'll look for angle QMN. Well, that's a central angle. It corresponds to the inscribed angle QPN as far as the intercepted arc, and the arc is 118 degrees, so the angle is 118 degrees. Next we'll look for some arcs. First is arc NO. That's this arc right here. And let's see, what do we know about this arc? Well, what we do know, there's a central angle here. We don't know that measure, so that doesn't help us. Is there an inscribed angle that we know? No, there's no inscribed angle. But what we do know is that it is part of a semicircle, that semicircle, for which we know the remaining portion. This part of the semicircle is 68 degrees, so the remainder must be 180 degrees minus 68, and I think that comes out to 112 degrees. Next we'll look for the measure of arc QP. That's this arc right here, and we have the same relationship. If this was a semicircle over here, well, this is a semicircle over here also. So 180 minus 118, 62 degrees. And then the measure of arc NOQ. Well, we have a choice here. We can either add up 112 plus 68 plus 62, or we could simply subtract 118 from 360. So let's see, 360 minus 118, 242. 242 degrees. So hopefully you were able to find all those angles on your own. Okay, our new theorem for today tells us that the measure of an angle formed by two chords intersecting within a circle is equal to 1/2 the sum of the measures of the intercepted arcs. So we're looking for the measure of this angle right here. And in fact, if we find that measure, we will also find this, because they are what? They are vertical angles. And the important thing is that the arcs we're interested in are the ones that are intercepted by those angles. These two arcs. These two arcs that are highlighted here are not going to give us this angle, because this angle does not intercept those arcs. It intercepts this arc over here and this arc down here. Make sure you've got that straight right from the beginning. Then we're just going to take the average of those two arcs. We'll add them together and divide by 2. We can multiply by 1/2 or divide by 2, either way. So, applying this new theorem, we're asked to find the measure of this angle right here, x. So we take the two intercepted arcs. Remember, this angle over here will also be x, because they're vertical angles. So we will take the two intercepted arcs, 110 degrees plus 30 degrees over 2. And that is going to give us the measure of angle x. 140 divided by 2 is 70, and x equals 70. In this example, we are not given the measures of both of the arcs that we need. We need these two arcs in order to find x. But we are given enough information to find the measure of this intercepted arc. So we'll take 360 minus 100 minus 110 minus 40. And let's see, that all adds up to 250. 250 from 360 gives us 110. So this arc is 110 degrees. Now we know both of the intercepted arcs. So 110 plus 40 divided by 2 equals x. 150 divided by 2 equals x. 75 equals x. So x equals 75. Here again, we're not given both of the intercepted arcs, nor are we asked to find the interior angle. We are given the interior angle, and we're asked to find one of the arcs. Well, we just set up the same equation. We'll take one arc, 135 degrees, plus the other arc, which in this case is x. Divide that by 2, and that will equal the measure of that interior angle, 100 degrees. Well, now we just solve for x. And like most algebra problems, there's more than one way to do this. I think the simplest thing for us to do will be to multiply both sides by 2. On this side, the 2's will cancel each other off, and we'll be left with 135 plus x equals 100 times 2, that's 200. We'll then subtract 135 from each side to get x by itself, leaving us x equals 65. Here again, we're going to set up an equation. The first arc has a measure of 2x. The second arc has a measure of x. So we add those two together, divide by 2, and that equals the interior angle, which in this case is 45 degrees. Again, it's algebra, more than one way to do this. I'm going to go ahead and combine like terms in the numerator, giving us 3x over 2 equals 45. We'll then multiply each side by 2 again, like we did in the last example, times 2. On this side, the 2's cancel each other out. Remember, let's look at this another way. When we multiply by 2, we can also think of that as 2 over 1. Just in case you didn't see why that makes this cancel. Now it's like 3x over 1, which of course is just 3x, equals 90. We'll divide both sides by 3. X equals 30. Here we have an interesting problem. We're given two arcs that are equal. When the two arcs are equal, if we say 88 plus 88 divided by 2 equals the measure of angle 1. That's this angle right here. Well, 88 plus 88, let's see, 88 plus 88, that's 196. And then 196 divided by 2, of course, is 88. So the measure of angle 1 equals 88 degrees. Well, notice that since the measure of the angle and the measure of the intercepted arc are equal, what do we know? We know that angle 1 is in fact a central angle, and that this point right here is the center of the circle. Alright, so that's interior angles formed by chords intersecting. Check its learning for your practice problems in this section, and come to class with your questions.